This question is to evaluate the integral on contour C, z squared minus 1 over z dz. And the contour C is expressed as z equals 2 times e to the power of I theta, where theta is from 0 to pi. So in this question, we have z, and we can also use theta to express z. So the first step, we just need to substitute z equation into this integral function. And note that we have this equation dz. So next step, we need to change this dz into some equation times d theta. And since we know theta is from 0 to pi, so this given integral function becomes integral from 0 to pi. Z squared, we just need to substitute z using theta, minus 1 over z, which is 2 times e to the power of I theta. And then the dz becomes 2 times e to the power of I theta times I d theta. So now at this step, we change the function about dz into the function about d theta, and we know theta is from 0 to pi. These two items can be cancelled, so the equation can be rewritten as integral from 0 to pi I times 2 times e to the power of I theta squared minus I d theta. And the next step is that we need to find the antiderivative of this function, which is 2 times e to the power of 2 times I times theta minus I theta. And you can double check if this equation is the antiderivative of that integral function. And the next step is that we just need to substitute theta using pi and 0 and do the simple math. And the equation becomes 2 times e to the power of 2i pi minus I times pi. This equation is that we used the pi to substitute, and then minus 2 times e to the power of 2 times I times 0 minus I0, because we use 0 to substitute. Do the simple math, we have 2 times 1 minus I pi, and then minus 2 times 1 minus 0. So the final answer is minus pi I.